Indices and logs. Logs, type 3, simultaneous equations. So like any simultaneous equation, we're going to have two variables in our equations, and we're going to be given 2. And of course, we're going to have to change it from log form back to algebra form before we can solve our simultaneous equations as normal. For example, we're asked to solve for x and y here, where the two equations given to us are log 2 to the base 2 plus log x plus 1 to the base 2 equals log y to the base 2. And the second equation is log x to the base 2 plus log y to the base 2 equals 2. An important thing to note in this question here is that we're told this fine print that x has to be greater than 0 and y has to be greater than 0. And of course, if we look at both of those equations, we have a log y. So that means if y is not greater than 0, we're going to get undefined. And same with the second equation, we have a log of x and a log of y. So again, if x and y is not greater than 0, we will get undefined. So like any simultaneous equation, we're going to start by numbering the equations. I'm going to call the first one equation 1 and the second one equation 2. And I'm going to separate my page in half here, and I'm going to work with one equation at a time. So I'm going to have to make log 2 to the base 2 and log x plus 1 to the base 2 equals log y to the base 2 into a single log on the left and a single log on the right. Now I know by looking at page 21 in my maths tables that if I'm adding my logs, I'm going to multiply. So therefore that's going to become log 2 times x plus 1 to the base 2 equals log y to the base 2. And of course I should have reminded us that we have to check the bases are the same on both sides before we can apply those rules. And of course I can see that they're all to the base 2. So now I have a single log on the left equals a single log on the right. The bases are the same, so that implies the numbers must be. So therefore, in other words, 2 times x plus 1, which is 2x plus 2, must equal y. So this is our equation 1. And now if I do the same with the second equation, again it's adding logs, which means I'm going to take log x to the base 2, log y to the base 2 equals 2. And I'm going to multiply those logs because it's the adding rule. So that's log x times y to the base 2 equals 2. And now this time I have a single log on the left equals a number on the right. So again, if I look back at the top of page 21, I'm going to have to change from log form back into index form. So again, when I'm doing that, I always like to write my base is a, the number is y, and then equals 2 on the right hand side, there has to be the x. So therefore that's going to become a to the power of x equals y. So in other words, 2 squared equals xy. So 4 must equal xy is my second equation. So this is a linear and a non-linear equation for our simultaneous equations. And therefore, because I have y equals 2x plus 2, wherever there's a y in the second equation, I'll replace it with 2x plus 2. So in other words, I'm subbing 1 into 2. So that's going to become x times y, which is 2x plus 2, equals 4. And if I multiply out my brackets, that's x times 2x, which is 2x squared, plus 2x, and I'll bring over the 4, so subtracting 4 from both sides. I can simplify that quadratic because it's equal to 0, so I'm going to divide across by 2. And now we'll look at what multiplies to give me minus 2, that adds to give me 1, and of course it must be 2 and minus 1. So that becomes x squared plus 2x minus x minus 2 equals 0. Group the first two, group the second two to get my highest common factor. So that gives me x by x plus 2 minus 1 by x plus 2 equals 0. Again, these brackets are the same, so I take that out as my highest common factor, which leaves me with x minus 1. Now both of them are multiplying to give me 0, which means one or both must be equal to 0. So therefore that gives me x equals minus 2 or x equals 1. But of course we have to go back to our fine print, and our fine print said that x had to be greater than 0, and therefore y had to be greater than 0. So clearly I have to discard x equals minus 2 as an answer and only take x equals 1 as an answer. And then I'm going to take my value for x, and I'm going to sub x into my first equation to solve for y. And therefore that's y equals 2 times x, so 2 times 1 plus 2, and therefore y must equal 4. Okay, so on the sheet then you're going to do questions 15, 16, 17 and 18. And again, remember to check your answers. And again, in question 15 and 18, there's no base. So remember that if there's no base and it's just log, well, that implies that it's log to the base 10.